Now in the last video, which was the first of the function series, we focused on relations. We said that functions are relations. It's just that the functions are a special type of relations. Good? And functions, we usually represent functions using equations, or we use a formula. Usually we use f of x, g of x, h of x, etc. Alright? So let's say, for example, we have a function f of x. Let's say f of x is equal to 2x plus 1. Let's say, and by the way, f of x, we use interchangeably with y. So from henceforth, you will be hearing me use, you'll hear me use f of x, or sometime I would say y equal to x plus 1. Alright? So we use these terms interchangeably. So let me call this x, set x, and let me call this set y. Let's say x is a set of all real numbers, and let's say y is the same set. Let's say x is represent the set of all real numbers, and let's say y represent the set of all real numbers. And in the set, so let's say you're using this relation. You have 1, 2, 3, 4. Let's say these are some of the elements in set x you're using. Now, according to this function, 1 will be mapped to what? Now, we normally find the mapping by finding f of 1. F of 1 just simply means that in the function, wherever we see a x, we replace that x with 1. So if f of 1 will be 2 times 1, which is 2, plus 1, that gives us 3. So in other words, this function maps the number 1 to the number 3. Let's say f of 2. F of 2 would mean you replace x with 2. So 2 times x will be 2 times 2, which is 4. And 4 plus 1, 5. So this function maps the number 2 to the number 5. Let's say you're asked to find f of 3. F of 3 would mean 2 times x, so 2 times 3. 2 times 3 is what? 6. 6 plus 1, 7. So it means that this function maps 3 to 7. And f of 4 mean you replace the x value with 4. So 2 times 4, that's 8. 8 plus 1, that's 9. So f of 4 is 9, meaning this function maps 4 to 9. And when we say the function maps 4 to 9, the word there maps in quotation. Right, don't be frightened by the word. Alright? When we say the function maps 4 to 9, all we are saying is that 4 would be like an input. So if you input 4 into the function, the output would be 9. Alright, so these are what we call input, and we have a name for, by the way, we have a name for this set. All the inputs, we have a name for it, we call it domain. And the output, each output, the set of all the output would call a range. Alright. And this is, by the way, there's also another term that we call codomain. I'll soon give you the difference between range and codomain. Alright. So these would be the inputs, and these would be what we call the output. Alright. So if you input 1 into the function, the output is 3. If you input 2, the output is 5. And so on. Now, notice the mappings. Notice the mappings for this function. Alright, mappings 1 map to 3. So if you're asked what are the ordered pairs for this function or for this relation, the ordered pairs would be 1, 2, because it maps, 1, 3, because it maps 1 to 3, right? What's another pair? 2, 5. These are what we call ordered pairs if you're asked for them. 3, 7, and 4, 9. And later on, when we're doing the graph of a function, These would be the coordinates you plot. And you connect them to graph your function. But we're not looking at that now, all right? We're just focusing on evaluating these functions. All right, so if you notice, the mapping, 1 to 1. All right, each element in X is mapped to one and only one element in Y. So it's a relation, yes, but it's a special type of relation. We call it a function. Good? Now, I just want to give an example of what a many-to-one function looks like. All right, a function f of x is defined as f of x equal to x squared plus 2. I ask you to evaluate f of a, f of 3. All right, so if f of 3 would mean that you replace the x with whatever is in the bracket. So you replace x with 3. So it will be 3 squared plus 2. And 3 squared is 9. 9 plus 2, 11. Evaluating f of minus 3 would mean that you come to the function here, you replace x value with minus 3. So it's minus 3 squared. Replace x with minus 3, so minus 3 squared plus 2. Now, when you square a negative number, a negative real number, of course, the value is positive, right? So minus 3 squared means minus 3 times minus 3, that's positive 9. And positive 9 plus 2, that's 11. Let's do this one. F of 5 will mean you replace the x value here with 5. So that's 5 squared plus 2. 5 squared is what? 25. And 25 plus 2, that's 27. So, if you should think of this function in terms of a mapping, this function, here can I squeeze it in now? This function maps the number 3 to 11, right? It also maps negative 3 to the same 11. And of course, it also maps 5. It also maps 5 to 27. Alright? So this is what we call a many-to-one function, because these two values, as a matter of fact, each of them is mapped to only one element over here, first and foremost. Right, so 3 is mapped to only 11. Negative 3 is also mapped to only one element over here. And 5 is also mapped to one element over here. Alright, so it's an example of a many-to-one function, because in maths, well, even in real life, sometimes, 2 is considered to be many. So here you have 2 elements in the set X here being mapped to one element in set Y. So this is also an example of a function. Alright? Once the mapping is a 1-to-1 or a many-to-one, then we consider that mapping to fit the description of a function. Okay, let's just focus on evaluating these functions now. So I have 2 functions. F of x is 2x plus 5 over x minus 2. And g of x is 3x squared plus 4x minus 1. And we're asked to find f of 4. Now what exactly are they asking us to do? So here's the function f of x. And we're asked to calculate f of 4. So f of 4 means you come to the function f of x and you replace the x value with 4. So 2 times x becomes 2 times 4 plus 5 over, and then replace, remember you're always replacing the x value with 4, so over 4 minus 2. So what we have here, 2 times 4 is 8. 8 plus 5 is, that's 8 plus 5, 13. 4 minus 2, that's 2. So your solution, 13 over 2. Or if you want to put right that as 7.5, then that's up to you, or 7.5, whatever. That or anything equivalent, alright? Next one, f of minus 2. Again, we come to this function here, and we're going to replace the x value with minus 2. So 2 times x becomes 2 times minus 2 plus your 5. All over. Remember, we're finding f of negative 2. So you're replacing the x value with negative 2. So that becomes negative 2 minus 2. Denominator. Negative 2 minus 2. So what we'll have here now is 2 times minus 2, that's minus 4, plus 5, over minus 2, I don't keep the sign, that's minus 4. Negative 4 plus 5 is 1, minus 4, right? So that one is negative a quarter. G of 1. Now part C, you also find G of 1. So G of 1, we use a function that's defined as G of x, and we replace the x value with 1. So 3 times x squared becomes 3 times 1 squared. Plus 4x becomes 4 times 1. We're replacing the x value with 1. And your minus 1 out there. So this becomes, well, 1 to any power is 1, right? So that is 3 times 1, which is 3. 4 times 1, that's 4. Minus 1. So 3 plus 4, that's 7. 7 take away 1, that's 6. So g of 1 is equal to 6. So this function maps 1 to 6, right? And the final one, we're asked to calculate g of minus 2. So we come to the function g, and you replace the x value with minus 2. So 3 times x squared becomes 3 times minus 2 squared. Plus 4x becomes 4 times minus 2 minus 1. Let's break this down now. Remember order of operation, you record the power first. So negative 2 squared means you multiply negative 2 by itself. So negative 2 times negative 2, that's positive 4. And positive 4 times 3, that's 12. And positive 4 times minus 2, that's negative 8. And you have a negative 1 here. So what you have here is 12 minus 8, which is 4. And 4 minus 1, which is positive 3.